Hi all, welcome to another code snippet discussion. Today I've shared this piece of code snippet on my Telegram channel, and we are going to discuss on this code snippet. Probably this code snippet doesn't have any much of a complexity, but the main theme that we have to look from this particular code snippet is how we are utilizing the instantiation part. So the main theme here is the way we create an instance and the way we are going to invoke the member variables and as well as the member functions or the member methods. So that's the whole idea about this code snippet. It's pretty straightforward. We don't have much of concepts to be discussed. So without a due delay, let's get into action. And right now I'm just going to bring up my IDE, and here I'm just going to create the class called classroom, and I'm going to carry on with a main method as usually we used to do it. So here let's zoom in, and we have a base template, and we are going to create another class here. So we have a classroom which carries a main method. Along with this, we need to have another class called diary, and inside this diary class we are going to feed in an instance variable, and also we are going to have the instance methods. So I'm emphasizing here that it's all about an instance method and an instance variable, because we have seen many code snippet discussions before. We come across multiple terminologies, like for example static variable, final static variables, instance variables. So we need to be very specific on what type of a variable are we reading out from the code snippet. So based on that only we can able to predict the output of the code snippet. So as I said, that here we are going to have the instance variable. So I'm going to declare it a variable of type int, which is a primitive type called page count, and this is going to carry a explicit value called 100. So what you have to notice here is this is an instance variable. It doesn't need any explicit initializations at the beginning time, but as per the code snippet we have given a explicit value called 100. Otherwise it's going to take a default value of 0. So what we are going to do with this variable, that's the question that we have. So this variable is going to be set with a setter method, and we will be getting the value of this variable through a getter method. So this is pretty familiar methods that we usually use in Java. People who are new to this getters and setters, probably you don't need to worry. I'll just try to explain a bit of information on this setter and getter. So right now we go ahead and start creating those getters and setter methods. Those are just prefixing with get and set, so that we can call them as a getter and setter. But apart from that, they are all going to be considered as an instance method, a normal instance method. The only thing that gets highlighted here is it's going to be called as a getter and setter, because we are prefixing it with get and set. So with that piece of information, since we have an instance variable of type int, equivalently to this instance variable, we need to create a getter. Okay, so getter means get the value from that instance variable. So typically you're going to return that instance variable. So we need to carry a return type. So since it's an int, so we are going to carry a return type of int, and get page count. You have to notice that we are following the naming standards as per the standard naming conventions. Okay, so we prefix here with get. So that's the point here, that's the catch here. So it's the getter method, right? And we have a return type here. So return type is integer. Since the page count is integer type, we are going to return this page count here from this method. Okay, and the name, the identifier for this method is get page count. So it's a lower camel case. Naming standards are something which is pretty important to follow universally. So it's going to be prefixing with the get, which represents that this particular method is going to be called as a getter. But the thing that you have to notice here is the whole word, the get, the whole word is in lowercase, and the rest of the words like page, count is all starting their first character with uppercase. So this is actually called as uh, lowercase method naming conventions. We can even call them as lower camel case. Lower camel case. Okay. Equivalently, we have an upper camel case. Okay. So this is an example of upper camel case. If you look at the class name, the interface names, those names will all follow the standards of upper camel case. Upper camel case. Why it is called as an upper camel case? Because all words, you have a two words or three words or four words in a class name, doesn't matter, all the words, all its first characters should be represented in the uppercase. So that's why we call it as an upper camel case. And for the method naming conventions, for the variable naming conventions, those will have the lower camel case. Okay, so that's enough about the naming conventions. Let's get into the code. So here we have the page count method, and we are going to return there is an error here. It's because it's expecting some return from this method, and that should be of type integer. So what we are going to return is the page count. Return this dot page count. So we can either invoke this page count with the this keyword, or without the this keyword it's going to be the same, because implicitly it's going to be applied with this dot page count. This keyword represents the current instance on top of which this method is going to be called. So it's going to represent that instance. If I don't have this, will it make any big difference? Not at all. It's implicitly carrying the this keyword there, but it's something that a practice that we follow at times, to call it with this dot page count, or even you can call it without this keyword. Not of a much big difference. And let's go for the next important method, which is called as a setter. Setter, as the name suggests, that it is going to set the value to the instance variable. So it's not going to return anything. So typically we are going to carry a return type of void, and prefixing with set. Set for whom? Set for the page count instance variable. So you need to call the variable name appended to this prefixing word called set. So we go ahead and say page count, and we are still following the lower camel case. So set word completely in lowercase, page and count as usual, that we are carrying their first character started with uppercase, but still it's going to be called as a lower camel case naming standard or the naming convention. So we are not going to return anything, but we are going to set the value. So if you are going to set the value, then probably the setter method should carry an parameter. So let's say, as per the code snippet, we have int val. So I guess you all knew what's going to happen here. This dot page count equals val. So what happens here is, while you're invoking the set page count method, you're going to forward a value. Okay, you can pass on a value to this parameter, and it's going to be an integer, and that integer value is going to be assigned to this page count. Now again, this comes in handy for me, because I keep writing this always whenever we are invoking the instance variable within the getters and setters. But nothing harm in removing that, because we follow the code snippet that we have seen on the image just now. So I'm going to remove this keyword, and we are good to go. So we have set the value here, right? So the value that you're passing to this method is getting assigned to this page count. Implicitly, still there is an existence of this keyword. This dot page count happens. Okay, so now let's see how we are going to invoke these methods and the variables out inside the main method. I guess this is pretty straightforward. We have an instance variable, we have a getter, and we have a setter. So let's comment it out, calling it as an instance variable, and here it's going to be called as getter method, and it's an instance method, and this is a setter method. This is again a instance method. So the meaning of instance method is it's going to be invoked on top of the instance. So we are going to create a statement here, which is going to be of a sysout, and in the sysout, inside the sysout, we are creating the object for the class called diary. That's what we have here, right? So the name of the class is diary, and we create an instance for the diary class and go ahead and invoke the getter method. So we have an access to the get page count, even though it is defaulted access modifier that we have, default access modifier. We still have an access because we are all in the same package. The class classroom and the diary all belongs to the same package. So we have access to the method get page count. So this is the very first line that we have in the main method. And if you observe, I have just created an instance. I'm not using any reference variable in order to store this instance. That's the tricky part of this particular code snippet. We are creating an instance directly, and we are not storing them in any reference variable. So usually what happens is we'll be creating a diary, an object reference variable. It's a variable, and we say new diary, right? So this is how we actually create an instance, thinking that this instance can be reused at later point of time. In order to use this instance at later point of time, then we need to capture them in one variable, and that variable is of a custom type variable. So we need to denote that it's a diary variable, and this variable is going to hold the reference of this instance. So, but luckily here we don't have any such standards of syntax. We directly go ahead and create an instance. The instances are something which is essentially required in order to call the members of the class. So all these members belongs to this instance. Okay, so we have created an instance and we have invoked the getter method. Next to this line, we have another instance creation for the same diary class, and go ahead and invoke a setter method this time. So I'm going to set the value of 100, and if you notice, the set the value to 200. It's a typo. So if you see here we have 100, which is a initialization that happened to the page count, and later we are setting it to the page, setting the page count to 200. Okay, so now you can understand that why we need to use a setter method. Setter method is used to set the value to the instance variable. We are calling the set page count method. Later on, we are going to have another sysout statement, and in this sysout statement, we are going to create another instance diary and dot get page count. Again, we are invoking the get page count method. So there are three different calls are happening. Line number 18, we are calling the get page count. Line number 19, we are calling the set page count. Line number 20, we are calling the get page count method again. But what is something unique here, even though it seems to be more of a caller to the methods, but there is something unique. So if you see 18 is carrying one instance. Okay, so let's assume that I have created one instance here. And line number 19, again we are using the new keyword in order to create the instance for the diary class. So we have another instance of the same diary. And in the sysout, line number 20, we again create one more instance. Okay, one more instance. And this instance is having another reference. So now keep in mind, the moment we create an instance, okay, it's going to invoke the default constructor, and we already have the default constructor here. So if you notice, we have a default constructor in this class, and it invokes the default constructor, and it's going to get the page count variable assigned to it, which is going to carry a value called 100, default value called 100. So this is the first instance that we have created. So this instance is going to carry a integer memory, and in that integer memory, it's going to carry the value called 100, right? The same way it's going to happen for the other instances as well. So every individual instances is going to carry its own integer variable memory allotted with a value called 100. Okay, so what's the output? Let's see. If you look at this new diary get page count, so initially the value is going to be 100. So we are getting the page count without even modifying the value. We are getting the value of the page count variable, so it's going to print 100 at this point of line number 18. But look at line number 19. Line number 19 is saying 200. Set the value of the page count to 200. So this instance is going to set the value. But notice this is instance 1, this is instance 2, and this is instance 3. Right? So in this instance, with this instance, we invoke the get page count. Default value in all the instance for the page count is going to be 100. Okay. So it's going to get the 100 and display it. New diary, you are setting it with this instance. Default is 100. You are setting it using the set page count as 200. And at this time, if you see here, it's going to carry a new updated value to this page count as 200 instead of 100. But that's going to happen only in this particular instance. Okay. And relatively, we have the third one, the third instance, and that is carrying a default value for this page count as 100, a separate memory of the page count in its reference, carrying the default value of 100. Now here it's the line number 20, which is going to create an instance of new diary, new instance. This is the third instance, that is line number 18, and this instance is coming out from line number 19, and this is instance coming out from line number 18. So here the output is 100 for this 18, and for 19 it's a new instance which is carrying a default value of 100, and it's going to call the get page count, and you're going to get that default value called 100, and you're going to print them using the sysout. Now the big question is, what happened to this 200? Will this 200 not impact this third instance? Obviously it will not impact the third instance, because this change or this update is very much personal to this instance alone. The second instance, this change of the page count for this instance will not impact neither the instance 1 nor the instance 2. That's the key point of this particular code snippet. Each instance is going to carry its own memory allotted for this page count. So every individual instance is going to carry a personal copy of the page count, and it's going to allocate the 4 bytes of memory. Int takes 4 bytes of memory. So this instance will allocate 4 bytes, this instance will allocate 4 bytes, and this instance will allocate 4 bytes for this page count in their references. And the default value throughout them is 100. And in 19, line number 19, we set the instance 2 to set the page count to 200, so that from 100 it gets modified to 200. But this change of 200 is not going to impact any of the other instances. They have their own copy of page count. That's what the deal here. The instance variable means it's going to have, the instances are going to have its own copy of the instance variable. So probably few might have thought that this change of 200 might impact this get page count also. No, it won't, because it's a new instance. Whenever you see the new keyword, we are actually entitled to create a new instances of the particular class. So my output, my predictable output as per the sysout, line number 18 it's going to be 100, and line number 20 is also going to be 100, and that's 19 update of 200 is not going to impact this line number 20. So 100 is what I'm predicted with. So I guess there is a print statement, println. Okay, so we have a println. It's good. So let's go ahead and execute this program and see if my understanding is correct. Yes, of course. So whatever I've explained is what you're viewing it as an output. So this code snippet is throwing an output of 100, and what happened to 200? It's still there in the second instance, but we are invoking a new instance, and on top of the new instance we are calling the get page count, and the default value for that particular instance page count variable is 100, and that's going to be printed. Okay, so that's the catch behind this code snippet. I hope you would have got some insight about it. If in case you have any queries, please feel free to drop in your queries on the comment section, and I'll try to answer it at my best. So The final understanding of this program is we have learned many things out here: declaring an instance variable, getting to know about the getters and setters, and then the most important thing is creating an instance without storing it in a reference variable. If it were stored in a reference variable, all these might change. Okay, all the output what we have seen might change, because you might be reusing the same reference variable in order to call the setters and getters. But that's not what happening here. And the tricky part here itself is very clear, that intentionally it has been created with a new instance to get to know the understanding of how the instance variables are manipulated by every new instance that you create. So with that, I guess we got some update on the instance variable usages. So we'll see in another interesting code snippet. Until then, have a great day. Bye.